Today, we're diving into a really cool scientific quest, the search for a gear oil that's super tough, but also good for the planet. Let's jump right in.
Okay, so here's the question for you. What actually keeps our entire world from just grinding to a halt? I mean, think about it. Cars, factories, all these huge machines with tons of moving parts. Why don't they just lock up and become a giant paperweight?
The answer? Lubricants. Oils and greases. They're these unsung heroes that create this tiny protective film between all those moving parts. It's that little layer that cuts down on friction and stops our machines from literally tearing themselves to pieces. They're pretty much the invisible force that keeps everything running smoothly.
But, and this is a big but, that brings us to the core problem we're talking about today. We're all trying to be more environmentally friendly, right? So the big challenge is finding a lubricant that can do the heavy lifting and be kind to the planet. So here's the trade-off. On one hand, you've got your traditional mineral oils. They come from fossil fuels, they're not great for the environment, kind of toxic, but man, do they perform well. On the other hand, you have biolubricants, made from things like vegetable oils. They're renewable, biodegradable, fantastic. The problem? They just don't hold up under pressure. And when I say pressure, I mean extreme pressure. Just picture the inside of a car's gearbox. The forces between those meshing gear teeth are insane. We're talking immense pressures and temperatures that can spike up to 1,000 degrees Celsius. A regular bio-oil, it just can't take that heat. The protective film breaks down and, well, things go very, very wrong.
So, the big question is, how do we beef up these green oils? The answer lies in additives. Think of them like performance boosters. And in this particular study, scientists zeroed in on one really promising candidate, boron.
And why boron? Well, on paper, it's a rock star. It's ashless, which is a fancy way of saying it burns clean. It's a great antioxidant, so it stops the oil from breaking down. It prevents rust, it fights wear and tear. I mean, it really seemed like the perfect ingredient to solve this whole problem.
Okay, so they had their champion. Now it was time for the ultimate stress test. The researchers mixed up a few different lubricant recipes to see if boron really was the magic bullet they were hoping for.
So here's what they mixed up. Recipe 1 is just the basic bio-oil. That's our baseline. Recipe 2 is the one we're really watching, bio-oil plus boron. Then, for the other recipes, they added boron along with some other common additives, like phosphorus and sulfur, just to see what would happen when they all played together.
So how do you test this stuff? With something called the 4-ball test. It sounds simple, but it is absolutely brutal. You've got 3 steel balls locked in place, covered in the oil. Then a 4th ball spins on top of them at high speed, all while they're cranking up the pressure, more and more and more, until the oil fails, and the heat is so intense, the balls literally weld themselves together. That's the weld point. The higher that number, the tougher your oil is. Simple as that. All right, the stage is set, the test is running. So, did boron work? Did it give the bio-oil the superpowers it needed? Well, what happened next was not what anyone expected, and it led to a really amazing discovery.
First up, let's look at our baseline, the plain old bio-oil, no additives. It tapped out pretty early. The balls welded together at a load of 200 kilograms. So, 200 kilograms is the number to beat. Then came the big moment, the recipe with boron. And the result? Well, let's just use the researchers' own words here. They said, the additions of boron did not contribute to any improvements. Talk about a letdown.
Yep, the weld point was still 200 kilograms. Zero change, nada. Our hero additive, all by itself, did absolutely nothing. It was looking like a total bust.
But wait, then they looked at the other recipes. When they paired boron with a phosphorus additive, the weld point went up a bit, to 250 kilograms. Okay, better, but not amazing. But then, look at this. When they mixed boron with the sulfur additive, the weld point skyrocketed to 400 kilograms. It literally doubled the performance. It turns out boron wasn't supposed to be the solo hero, it was the ultimate team player.
This is a perfect example of something called synergy. It's that idea where the whole is greater than the sum of its parts. It's not 1 + 1 = 2, it's more like 1 + 1 = 3, or in this case, even more. Boron and sulfur together did something that neither of them could ever do on their own.
So you might be thinking, okay, cool lab experiment, but what does this mean for the real world? Well, this discovery is actually a really big deal for the future of lubricants and, every machine that relies on them.
So let's just tick off the big wins here. They doubled the oil's strength.
They got great protection against breakdown and rust, but maybe the most important thing? They found a path to making super tough gear oil without a lot of phosphorus.
And why is low phosphorus such a big deal? Well, phosphorus is a common ingredient in tough oils, but it's terrible for the catalytic converter in your car. That's the part that cleans up your exhaust. So by finding a way to make a high-performance oil without it, this research is basically pointing toward lubricants that not only protect our engines better, but also help us keep our air cleaner. It's a win-win.
You know, this whole journey from a tricky problem to a completely surprising solution is a great reminder that this kind of innovation is happening all the time, just out of sight. It kind of makes you wonder, doesn't it? What other everyday things are getting a quiet green upgrade in a lab right now?